In this video, we're going to apply optimization to fuel economy. So we're driving a small hybrid car and we have fuel economy E is in miles per gallon. And we want to figure out when it's most efficient. We know it's going to be somewhere between 20 and 70 miles per hour. So when they build and design cars, they don't build them so that they're most fuel efficient going 2 miles per hour. That's not realistic. Neither is going 200 miles per hour. So somewhere between 20 and 70 miles per hour, we want to figure out when is this going to be most economical in miles per gallon. So we are going to look at speed S in miles per hour and say what the fuel economy E is in miles per gallon. So we're going to be looking at this objective function. This is what we're trying to optimize. We have our objective, optimize fuel economy. And then we also have our interval. The interval of interest, we would never tell somebody, oh, just drive 5 miles per hour everywhere. No, we're gonna look between 20 and 70 miles per hour. What's gonna get you the most fuel economy? So we're going to take the derivative of our objective function. So we're going to take e prime of s, bring down our power. We're going to have negative 0.03 times 2 is going to give us negative 0.06 s to the first. Derivative of 3.18 s is just going to be 3.18. And the derivative of negative 40.1 is 0. So there's our derivative. We want to set it equal to 0. We're going to solve this like a linear function. We have an mx plus b. We want to just get s on one side by itself. So first off, we can subtract the 3.18 from both sides. So that we have negative 0.06s equals negative 3.18. And then we don't want to multiply by negative 0.6. We want the s on one side by itself. So we're going to divide to get rid of that multiplication. And say s is negative 3.18 divided by negative 0.06, which is going to be s is 53. And what is speed measured in? It's measured in miles per hour. So we're going to see what's best for fuel economy. Do we want to go pretty slow? Figure out the miles per gallon for 20 miles per hour. Do we want to go usually as fast as what's legally allowed is around 70? Is going faster going to be better for our fuel economy? Or our critical number is on this interval of interest, so we would test it 53. If our critical number was 92, we wouldn't even test it. We're only looking at speeds between 20 and 70 miles per hour. Now I'm going to plug these in to compare their y values. So of course I'm going to plug into the original function, not the derivative. The original function gives you y values. So plugging in 20 miles per hour into the original function, I'm getting 11.5. And what is E measured in? It's measured in this miles per gallon. So if your average speed is going to be 20, you're going to get 11.5 miles per gallon. Not the best unless maybe this was a truck, but we're given it's a small hybrid car. So I would suspect a hybrid car would have better miles per gallon than that. So let's see what happens with 53. Hopefully it improves. So plugging into the original function, they're going to get 44.17 miles per gallon. Much better than 20 miles per hour. Way better fuel economy. But what happens if they go even faster? Are they going to have better fuel economy or worse fuel economy? So far going from 20 to 53 helped, but what about if we jump to 70? Is it going to help again or is it going to be worse? So if we plug in 70 to the original function, we're going to get 35.5 miles per gallon. So when we're advising somebody to try to conserve fuel, conserve energy, we would say that the speed for gas mileage to be most efficient Or in other words, best fuel economy. Is what? It says at what speed is the fuel economy the greatest? What would you choose, 20 miles per hour, 53 miles per hour, or 70 miles per hour? Well, this one gives the best miles per gallon. So we're going to say the speed is going to be 53 miles per hour. That gets them the most miles per gallon.